Hello students, I am Vishwajit Nath. Welcome to my YouTube channel Best Physics Guide by Vishwajit Nath. Today I am going to discuss about work, power and energy. Let capital F force is applied on a body. The displacement of the body is r vector. Now the angle between F vector and r vector is theta. Therefore, the work done by the force on the body is W is equal to F vector dot r vector. That is W is equal to mod of F vector mod of r vector cos theta. This is the expression of work done by the force on the body. You know that we can resolve F vector into two mutually perpendicular components. F cos theta component acts along the displacement of the body and F sin theta component acts in the normal direction of the displacement of the body. Therefore, the component of the force F cos theta is responsible to displace the body by the along the r direction. But the component of the force, that is F sin theta, has no role to displace the body. Therefore, the work done by the force on the body is displacement of the body, and the component of the product between the displacement of the body and the component of the force which is responsible to displace the body. That is, work done is equal to the displacement of the body or magnitude of the displacement of the body r into the component of the force, that is F cos theta, along the displacement of the body. That is, to find out that work done by the force on the body is, we can apply the dot product between F vector and r vector. You know that work done is a scalar quantity and the unit of work done is joule in SI system. That is, 1 joule is equal to 1 Newton into 1 meter. This is the work done of the, this is the unit of work done in SI system. Joule is the unit of work done in SI system. In CJ system, the unit of work done is arc. 1 arc is equal to 1 dyne into 1 centimeter. 1 arc is equal to 1 dyne into 1 centimeter. When the applied force is a function of displacement r, that is F is a variable force, then to find out the work done, we have to integrate the F dot dr. That is, work done W is equal to integration r1 to r2 F vector dot dr vector, or integration of r1 to r2 F cos theta dr, where theta is the angle between F vector and r vector, and r1 is the initial position of the particle or body, and r2 is the final position of the body. When theta is equal to 0, then the work is done by the force. That is, when the displacement of the body is along the direction of the applied force, then the force, the work done is positive. And when theta is pi, that is, the displacement of the body is opposite to the direction of the applied force, then the work done is negative, or work is done against the applied force. And when theta is equal to 90 degree or pi by 2, then no work is done by the force. That is, this force is known as no work force. When a particle moves along a circular path, then the work done by the centripetal force or centrifugal force is zero. This type of force is known as no work force. Now, work done in rotation of a body. Let tau torque is applied on a body with respect to the axis of rotation. D theta be the angular displacement of the body. D theta is the angular displacement of the body. Therefore, the work done by the torque is W is equal to integration theta 1 to theta 2 tau d theta. Here theta 1 is the initial angular position of the body and theta 2 is the final angular position of the body. When the torque tau is constant, then we can write that work done is equal to W is equal to tau into theta 2 minus theta 1. That is torque into angular displacement of the body. Work done is equal to torque into angular displacement of the body. But when theta is a function, when tau is a function of theta, then we have to integrate the function with respect to theta or d theta. Now power is equal to rate of work done. Power is equal to rate of work done. That is work done divided by time taken. Here T represents time and W represents work done. In calculus, power P is equal to dW dt. That is rate of work done. And we also know that work done W is equal to F vector dot R vector. Therefore, P or power is equal to F vector dot dr dt. Since we know that dr dt is equal to V is equal to velocity of the body or velocity of the particle. Therefore, power P is equal to F vector dot V vector. That is, power is equal to applied force vector dot velocity vector, or P is equal to power is equal to mod of F vector into mod of V vector cos theta, where theta is the angle between F vector and V vector. This is the expression of power. Unit of power is watt in SI system. 1 watt is equal to 1 joule per second, or 1 watt is equal to 1 Newton into 1 meter per second. Unit of power in CJ system is arc per second. 1 arc per second is equal to 1 dyne into 1 centimeter per second. Since 1 joule is equal to 10 to the power 7 arc, therefore 1 watt is equal to 10 to the power 7 arc per second. And unit of power in FPS system is HP. 1 HP or 1 horsepower is equal to 746.4 watt. 1 horsepower is equal to 746.4 watt. Next, energy. What is energy? Energy is defined as the ability of doing some work by a system. Energy is defined as the ability of doing some work by a system. There are 8 types of energy. First, mechanical energy, light energy, sound energy, electric energy, magnetic energy, chemical energy, atomic energy, and heat energy. All kinds of energy at last transformed into heat energy. Mechanical energy of a body are 2 types: kinetic energy and potential energy. Kinetic energy of a body is produced due to the motion of the body. Let v be the velocity of a particle, small m be the mass of that particle. Therefore, its kinetic energy is half Ek is equal to half m v square. Ek is equal to half m v square. This is the expression of kinetic energy of the body. We can prove it easily. Let a body having mass small m starts with velocity v. If force is applied against the motion of the body, therefore the body comes in rest comes in rest after covering a distance s. That is, its final velocity v prime is equal to 0 after the distance s. The body moves along a straight line. Now the retardation produced in the body is A, and therefore we can write that A is equal to v square by 2s. This is the expression of retardation of the body. And from Newton's second law of motion, we know that A is equal to F by m, since F is equal to ma, where m is the mass of the body. Now, equating equation 1 and 2, we can easily write v square by 2s is equal to F by m, or F by m is equal to v square by 2s. Now, the change in kinetic energy of the body is equal to work done to stop the body. Its initial kinetic energy is Ek and final kinetic energy is 0. Therefore, Ek minus 0 is equal to the change in kinetic energy is equal to force into displacement. This is the work done against the motion of the body. And we know that F by m is equal to v square by 2s. Therefore, we can easily write that Ek is equal to half m v square. That is, kinetic energy of the body is equal to half m v square. This is the expression of the kinetic energy of the body. Now, potential energy of a body. Potential energy of a body is equal to the energy stored inside the body due to the change in position or shape or size of the body. That is, the potential energy is equal to the work done to change the position or shape or size of the body. That is, when we lift a body against the gravity, then some potential energy is stored inside the body. This energy is equal to the work done to lift the body. When we stretch a string, then some potential energy is stored inside the body due to the stretching of the string or the work done against the elasticity of the string. Therefore, potential energy is equal to integration F dot dr R1 to R2. R1 is the initial position of the body and R2 is the final position of the body. F is the applied force and dr is the small displacement of the body. When a body is lifted up against the gravity, the weight of the body is mg. That is, here applied force F is equal to mg, where m is the mass of the body and small g is the acceleration due to gravity. H is the displacement of the body. Therefore, potential energy stored in the body is force into displacement. Here force is equal to mg and displacement is h. Therefore, potential energy is equal to mgh. Now, work done to stretch a spring, or potential energy stored in a stretched spring. Let K be the force constant of a spring, X be the increasing length of the spring after capital F force is applied on it. Now the potential energy stored in it is equal to integration of 0 to x f dot dx. And we know that here the magnitude of force or elastic force is equal to k into x. Therefore, potential energy stored in the spring is integration 0 to x k x dx is equal to half k x square. This is the expression of potential energy stored in a stretched spring. Now, the law of conservation of mechanical energy. When friction is neglected, then the total mechanical energy of a system always remains constant. That is, kinetic energy plus potential energy of a system is equal to constant. That is, change in kinetic energy of a body is equal to gain in potential energy of that body. Proof. Change in potential energy of a body, that is U2 minus U1, where U2 is the final potential energy of the body and U1 is the initial potential energy of the body. Therefore, change in potential energy of the body U2 minus U1 is equal to work done against the applied force. This is equal to integration of R1 to R2 F vector dot dr vector. This is equal to minus integration R1 to R2 F dr. Since the work done is against the applied force, therefore minus sign or negative sign is introduced. And we know that F is equal to Ma, or F is equal to M into dV dt, while V is equal to dr dt. Therefore, substituting the values of F and dr, we can write that work done is equal to M into integration V2 V1 V dV, integration of V dV. The lower limit is V2 and upper limit is V1. Since the negative sign is present, therefore we can reverse the limiting value by omitting the negative sign. By integrating, we can write that this is equal to half M V1 square minus V2 square. This is equal to U1 minus E2. U1 minus E2. Here U1 is the initial kinetic energy of the body and E2 is the final kinetic energy of the body. That is U1 is equal to half M V1 square and E2 is equal to half M V2 square. Therefore, U2 minus U1 is equal to capital E1 minus E2, or U2 plus E2 is equal to U1 plus U21. That is, the total mechanical energy at the final stage of the body is equal to total mechanical energy of the initial stage of the body is equal to constant. This is the proof of conservation of law of mechanical energy. Now, if delta M amount of mass is changed into capital E amount of energy, then we can write that E is equal to delta M into c square, where c is the velocity of light in vacuum. This is known as conservation of energy and mass theorem, which can be derived from Einstein's special theory of relativity. This formula can be derived from Einstein's special theory of relativity. Now, in the whole universe, the sum of energy and mass always remains constant. That is, the sum of mass and energy of a system or sum of mass and energy in the universe is always remain constant. This is known as principle of conservation of mass energy. That is, mass and energy can be converted into many forms. That is, energy can be converted into many forms, and mass and energy converted with each other. But mass and energy cannot be destroyed or created. The total sum of mass and energy always remain constant. Under a conservative force F, the work done is always zero when the displacement of the body is zero. That is, closed integration of F dot dr is equal to 0. Example: gravitational force, electrical force, magnetic force, etc. That is, when a body moves in a circular path inside a gravitational field or a magnetic field or a electrical field, then the work done becomes zero. Under a non-conservative force, F, the work done is not equal to 0. Although the displacement of the body is 0, but the distance covered by the body is not equal to 0. That is, closed integration of F dot dr is greater than 0, that is positive, when the magnitude of dr not equal to 0. That is, the displacement of the body is not equal to 0, then the work done is positive under a non-conservative force. Example of the non-conservative force is friction. For today, I am going to close my discussion, and please subscribe my channel. And thank you for watching my video. Have a nice day.